Good morning, guys. I hope you had a nice breakfast and then you're filled up with energy enough to make this mental shift and apply NASA coding guidelines to JavaScript. For me, this history started many years ago. And this talk is actually composed of two talks I was given before. The first talk is about exploring what boundaries of JavaScript could be. And then the second talk is about why we're not there and how to get there, how to ensure more trust into JavaScript. So my name is Denis Radin. You may find me on the network as a Pixels commander. I work in a company called Werkspot. It's also known in Germany as My Hammer. It's a mobile developer. Before talking about JavaScript guidelines, let's talk about the guidelines for this universe. One of the fundamental tendings of this universe is a tending to unification. So this universe respects unification. The shape of planets, the laws of physics, are constant everywhere. It's all going to be unified in this universe, this singularity. According to Wikipedia, unification is an effective method to decrease diversity. Aim for unification is to place elements in particular order, build a strict system which is comfortable to use. Decrease diversity, comfortable to use, strict system. Yes, there are sextillions of standardized units in this universe. They're very similar, a bit different, very individual, but still that tends to be standardized. And then humanity adopts this tending to standardization also. Every time we start something new, we start on some new field, as technology field, industry, or whatever, we start with a whole variety of possible solutions. It works for politics, for economics, for art, for engineering, and yeah, then we are going to talk about engineering most of all. As I said, in the beginning, we do the whole lot of possible solutions, but then on the best, most efficient survive. Can you see a plane in the background, right? Can you distinguish, is it a Boeing or Airbus? Maybe someone can. Actually, me not, to be honest. And this one is very similar. Really, only specialists can distinguish a Boeing or Airbus. If you go to the plane, you can read somewhere it's a Boeing or it's an Airbus. But it was not like that in the beginning. It was a 10-wing planes or rotating wing planes. Some crazy constructions. The same kind of story we see in software development. We developed software for 60 years, but such a common thing as defining a UI is not standardized yet. It's not standardized yet, so it still looks like early ages of aviation. So let's try to compare early ages of aviation with our current state or what we recently had in a front-end developer and compare solutions, front-end development, with the solutions, okay. Solutions used on the early ages of aviation. So yeah, as I said, 60 years of trying to make things standardized in UI development industry, in software development industry, but we still don't have standards. It reminds me of early ages of aviation, when we have this whole variety of solutions for just make human flight. Let's try to compare early ages of aviation to early ages of software development we have now. With this amazing video. Oh, technologies. What kind of technology is that? Microsoft Silverlight. Adobe Flex. It's a good try. It's completely amazing, so naive. That's the Flash. It's almost did it, and I was pretty fast. my favorite. It's even not shooting himself into the leg, but just it's Java applets. So yes, basically, as I said, once we start something, we try all kind of different solutions, but then only best survive, and the same works for software engineering also. For any kind of engineering. So yeah, all planets around, the laws of physics are constant everywhere, and all UIs are going to be unified. And what is going to be the standard for UIs? Let's guess. Let's guess. Yes. I want it, you want it, everybody wants it. It's going to be a web platform. We all believe it. That's why we're here together on this conference. And since I'm a big fan of aviation, once I tried to combine two my passions, passion to JavaScript, passion to web technologies, and a passion to aviation. And then I thought, okay, aviation also have UIs, and then if aviation is standardized very well by itself, then UIs in aviation is going to be standardized with a standard in UI development. So why not to build your aircraft instrument with HTML JavaScript? Why not? Okay, there is a motivation for that. There is a motivation in terms of unification, reliability, and accessibility. So first of all, we live in the age of drones, unmanned drones, then access to a state of a flight mission via HTTP, for example, is a pretty good thing to have. Then unification means that we have a lot of developers developing with JavaScript and web technologies, and it's not that hard to develop a flight instrument, to be honest. I mean, just display interfaces. And it's a good unified technology. Also, if you think about that, web platform is amazingly reliable. The billions of users daily opens billions of pages. And they constantly contribute to a safety and reliability of a platform. And also, once we have unified technology to develop instruments, we can establish a components market for aircrafts. And some of you can develop aircraft instruments and sell them to Boeing, for example. Just, yeah, why not? OK, once I saw that there is a motivation, let's try to do that. It was not hard, to be honest. There were some caveats, but then we ended up by a real flight on a real plane. It was flying above Amsterdam, around 1,000 meters heat. It was a real HTML, JavaScript thing, and we were relying on it. So yeah, it was maybe, yeah, it was cool actually. So first ever flight with HTML, JavaScript-driven instrument. But then, OK, we did it. The considerations there, stuff there to consider was, of course, reliability. Of course, we need, if you have problems with your instrument, you are fucked up, really bad situation. Then memory leaks is probably the most obvious thing to take care of, because once you have memory leaks, you have less responsive instrument, and it's bad, or even can make crash. Then resources consumption efficiency. Also to think about, maybe for this you can use GPU accelerated paths or alternative rendering methods of WebGL or Canvas. OK, so now you can imagine. You came into airplane. You take a place in airplane, and someone says to you, hey man, flight commander have a JavaScript-driven instrument in his cabin. And you are going to fly on a Boeing, on a JavaScript-driven Boeing. The web developer, JavaScript developer, drop few lines of code, and you are going to fly with that. You're going to be scared. You're going to be scared, definitely. Or not? Who will fly this plane? OK, it was quick, like a pack. Yes. But just let's think why you're not going to fly this plane. It's basically your perception of yourself. Your perception of web development and your perception of JavaScript development. It's basically your trust in yourself, it's your trust in the web platform, it's your trust in guidelines, in what's normal for JavaScript. Of course, it's easy to understand why it happened, because the price of mistake, of error, is very cheap in a JavaScript world. You just reload the page, everything starts again, you're safe. But then there are some missions when it's not like that. And then, with evolving of a web platform, JavaScript language, we have more and more of such missions. And we need to rethink our guidelines and rethink what's normal for JavaScript. And change the way people perceive JavaScript and how we trust ourselves. So we need more guidelines, probably, to change the way what's normal. Let's have a look at the Jet Propulsion Laboratory, which is an institution. It's a NASA kind of a branch, which works on projects like Curiosity Mars rover, right? And the Voyager. And the Voyager is amazing, because it's 36 years flying in a deep space without any bugs. Can your JavaScript do that? 36 years. No, but then we had a similar problem. Not 36 years, but when I used to work for 4 years in Unity Media on a project called Horizon, we had a set-top boxes. The set-top boxes had an JavaScript-driven operation system with 500,000 line of codes, and the stability and performance were pretty high priorities. Like 1 month without a reset, it was pretty challenging. So we tried to adopt this NASA guidelines. It's not a fish. It's not some weird thing. It's really guidelines which GPL use and NASA use, and they're published online. You can check them. So yeah, let's try. Rule number 1: no function should be longer than what can be printed on a sheet of paper. It comes from old times. Oh, you may have seen this photo. It's Margaret Hamilton is the author of Apollo mission source code, staying with the source code, basically. And then it's easy to understand why they were talking about sheets of paper at that time. But now we can rephrase it, do one thing. In one function, you do one thing, then it means higher readability. So comparing to what you have written all together, you can compose your functions, refactor functions better. Better composability also. Then, do one thing, please. If you don't do it, but it's obvious. It's really easy to adopt this rule. Rule number 2: restrict all code to very simple control flow constructs. Do not use goto statements and direct or indirect recursion. Okay, goto is easy to understand, but what about recursion? How can we live without recursion, and why NASA want to be? So actually, the reason for that is that NASA relies on static analysis a lot, and they want code to be predictable. First of all, predictable. Then they use static analysis for that. So for us, it sounds like rule number 2, predictability. If you want to write reliable code, drop to write cool one, and then start to write predictable code. Define coding standards and follow it. Use static analysis, that's very important. Now, it's really a flourishing part of JavaScript. If you don't use static analysis, of course, you should start. Use static analysis to support standard and reduce chance for defect. Use ESLint with a whole lot of plugins and presets. And of course, Airbnb preset is a good place to start. And there is a whole lot of plugins. We'll go through some of them during this presentation. But yeah, there is a lot of nice things happening to increase the quality of your code and support the standard you established. Collect metrics, because you need to track how things are going in your code base, and analyze types. Good tools for analyzing types now. Rule number 3, do not use dynamic memory allocation after initialization. So, okay, it's really weird advice for JavaScript land, because JavaScript have dynamic memory allocation by default, and then memory is managed by JavaScript by garbage collection. And that's a problem, because we got too relaxed about that, and many developers just don't respect all this RAM thing. So, rule number 3, respect RAM, because garbage collection might become your enemy. I will not run into details because I had the slides, had these links, but then I don't think I have enough of time. I hope everybody knows why garbage collection is bad and how to, how basically work with memory leaks and how to. Or someone want to look how timeline works? No. Okay. Then yes, measure with DevTool timeline. How much memory are you going to use, then compare the state of your application, compare the snapshots of your application to see where are memory leaks, what the state of your system of your memory. Then, yeah, just take care of your memory. Manage your variables with respect. Declares variables at the top of the scope to increase visibility. Use ESLint vars on top. It's yeah, just to have one place to keep your variables. Sort them for predictability. Watch for memory leaks. Clean listeners and variables when not needed anymore. Use ESLint no unused vars, which is very important and many people use, but if you don't use ESLint, it's very important to start with that. So switch to JavaScript to static memory allocation mode with object pooling. I think some of them know that there is kind of an option to have less memory allocation during runtime. By using object pooling. So how it looks like, you create some set of objects initially when your application starts. For example, you create 256 objects. Then you have a function to get object from pool and then to put it back, release object. Then you always reuse this 256 objects, then it's less memory allocation. Of course, it's not static, right? But at least you tried. You can do that. Rule number 4. All loops must have a fixed upper bound. It also comes from NASA tend to have a good static analysis, but I don't think we should follow this rule. Like, we would like to have recursion still, and we would like to be flexible, because we would like to be efficient, first of all. That, yeah, there is a rule number 4 for NASA. Rule number 5. The assertion density of the code should average to a minimum of 2 assertions per function. 2 assertion. Assertion is not a unit test. Assertion is something running in runtime, and it checks whether the state of application matches given. So rule number 5 for us means, sounds like test well, right? Higher test density is less defects you get, for sure. Minimal amount of tests is 2 per function. Let's try it. Watch for anomalies in system state during runtime, generate and handle errors in case of critical situations. Measure coverage, but be aware, 100 coverage doesn't necessarily mean you have well-tested code, because coverage is a quantitative, not qualitative metrics. Then rule number 6. Data objects must be declared at the smallest possible level of scope. That's basically all about mutable shared state. And many of us, most of us, face this problem. There are good tools now in JavaScript world to solve this problem. Then things like Redux, all this unidirection flows and so on. But then, yeah, anyway, it's really nice to see that there is good matches between NASA needs, NASA problems, and our problems. So, and we already have some solutions for them. Yeah, it's also a good ESLint plugin there for checking the pureness. It was developed by Roman Melnik and works pretty well. I mean, for example, you can test your reducers for pureness and add some safety there for your team and something to standards. Rule number 7. This rule, NASA say they break the most often. Basically, it says the return value of non-void functions must be checked by each calling function. So you call function, then you immediately check, is it correct response from it? Not. Then NASA often break it. I don't think we are going to use it as well. So rule number 7 we skip. Rule number 8. The use of preprocessor must be limited to the inclusion of header files and simple macro definitions. Right, the preprocessor, C preprocessor. We have a lot of preprocessing right now in JavaScript also. But actually, there are 2 problems with that. So the first problem with preprocessing, with transpiling, is that you don't own the code you execute anymore. The browser executes. So it's pretty reliable nowadays, but still, you should keep in mind that the code you write is not the code you execute. And there is also a price with that, price in terms of performance. There are some projects which compare performance of ES6 features compared to transpilation engines. Sometimes it's identical. Oh, a few months ago, a year ago, it was very different. I mean, now there are a lot of green fields, but still some yellow stuff, and means 3 times slower, 2 times slower. Yeah, transpilation have a price, and you should be aware of that. Also, there is a cost for bundling and transpiling. And yeah, there is a table with differences of different bundlers. And the difference sometimes is 10, 15, 20%. So it's remarkable. You even may change your bundling system because of that, but I don't think you'll do. Rule number 9. The use of pointers should be restricted, especially no more than one level of the reference is allowed. Function pointers are not permitted. OK, it's hard to use for JavaScript because everything is an object, and then we have a lot of pointers. But yes, it still can be used because of in two ways. So one of them is call chains. So if we use large call chains, it's basically also level of dereferencing, as they say. We had less performance because every call by the chain takes some time, then it decreases performance. Also, it's all about the law of the metra. So loose coupling. So loose coupling is just an architectural pattern. It's even not about JavaScript or C. So yeah, if you have a dog, it's a classic example. If you have a dog, you shouldn't say dog body legs run, but then you just say dog run, and dog knows how to run by legs or tone or whatever. It depends on its own state. So loose coupling and a smaller call chains. Rule number 10. All code must be compiled from the first day of development with all compiler warnings enabled. Oh, this is basically the most important one. It's basically the way you perceive your process, it's the way you perceive your code base. And just let's name it, keep it green. Keep it green from the first day of development. And perceive your project as something serious from the first day of development. But I know some of you already started with a different approach. So you are already red. So what do if you already fucked up? What to do if you already red? So just don't panic. Don't panic. Simply prioritize your models, do tests, implement standards, implement stuff we were talking about. It was 10 rules of NASA. The 10th is the last one. They're short. But then, by trying adopting them and more things, more ESLint plugins, by establishing standards, by making your code base better, by improving the process, we can make this shift, which currently do not allow you to fly on a JavaScript-driven airplane. We can make this change. And to perceive ourselves differently. To perceive ourselves like developers who produce first-class code. To produce the same kind of code people in NASA and GPL produce. And I think if we go this way, if we constantly improve our code analysis tools, our process, and our perception of web development, our trust in ourselves, one day we are going to be there. One day we are going to be on airplanes. But I know some people already are on airplanes. There are people using Node.js on Boeings. It's not used for actual autopilot or whatever, but they standardize some NPM models. It's KLM in Netherlands. They standardize some NPM models to put on a rack, on a Boeing, an Airbus, so they really fly it with Node.js nowadays, KLM, and it works. It's not connected to a flight system, but they use it for media, but it was still a long way to standardize a lot of NPM and Node.js models for that. But they did it. I mean, JavaScript is already on Boeing and Airbus. So, yeah, let's try. And, yeah, why not ships, for example? Also, in Netherlands, there are companies building a ship instrument with JavaScript. If ships are there, if planes are there, what stops us? Only trust in ourselves, only our perception of web development, and our perception of JavaScript. That's it. Thank you.